watching the birth of a new General Motors car. It began 210 weeks ago in the minds of these people. Minds filled with ideas about research, design, engineering, customer needs,
You gotta schedule a little work.
manufacturing. Lasers to analyze combustion, new ways to make stronger magnets, robots that learn to paint, efficient aerodynamics. This is the GM team concept proven by the customer demand for the Chevrolet S10 truck, the Pontiac Fiero. Now for a brand new car. Vince Mendersky opens the meeting.
We have concept approval. We have the time frame. This is week 210 and we're counting down. Our assignment, very simply, is to design and produce a new contemporary luxury vehicle that will be the recognized leader, full size and world class. Now to start with, we should review again the product needs of our customers. Jack has that information. Jack?
Well, the key point about our customers is their expectations. They're high and getting higher all the time in every area.
Okay. Now we have some design proposals that we would like to show you. This is what we want. Brushed glass, we want a thin molding.
Feeling of spaciousness that will be given by this.
We'll start some sections. The exposed pillar will be a challenge. We might need
to put the high tech into this car that we feel it really should have.
Because the pillar and the lower structural surface here is very
Successful
critical.
six-passenger seating is definitely a must.
Yes,
The wind rush noise to the side glass.
image of elegance. That's our goal.
I think we have a feeling here that we can build on.
These are some of the most important measurements of a new General Motors car.
Okay, now let's see where your eyes are.
Because the car is designed around the occupants. That's why GM developed Oscar, precisely adjustable to represent passengers from very small to very large. Detailed drawings show lines of vision, mechanical components, interior layout. But drawings can't tell you how a car feels.
How does it feel, Don?
A sense of space. One detail.
So full-scale seating pucks are constructed. For the exterior, idea sketches, full-scale drawings, bodies sculpted in clay, and shapes tested in the wind tunnel.
Looking at the design now in play, I see we do have a large flow separation and a large wake at the end of the mirror.
Smooth every detail. Make it efficient.
That's much better. The airflow isn't breaking up now.
But don't forget the heart of it, the drivetrain. This is a mule, a rolling laboratory that lets engineers test and evaluate individual components before they're tested in the real car. And deep inside the car are the structural rails, designed with the aid of the computer and modeled in plastic. Studied, tested, hand-built in steel, finished in exacting detail, ready for their debut in the safety labs. At GM, safety begins at the beginning. Building any car calls for trade-offs.
Okay, Ron, let's have the bad news. Well, we've got a pretty significant problem here between the hood clearance criteria and where the clays are. Even with our most efficient conventional coil spring design, we need about 40 millimeters more room.
Joe, do you think a more compact spring design is feasible?
I think we can do it.
Time seems odd.
I don't have to tell you, Ron, that's going to have quite an impact on our design.
They must find a creative solution to get ride quality and a handsome, aerodynamically efficient design. They look at something new, a compact barrel-shaped spring.
The key is to increase the major diameter of the spring so that we can nest the upper and lower spring coils inside.
Joe, this design...
It fits, but will it perform? Ride and handling motions prove out in the lab. These will be truly world-class cars. Work starts starts on the plants to build the new GM cars, and the GM team concept ties together the people responsible for engineering the car and manufacturing it. The plant will have some of the latest state-of-the-art technology.
We've built quality control through
157 robots, advanced automation, and tight control at each step. The system even monitors itself constantly.
We can control this body to millimeters and fractions of millimeters.
18 robotic painters will be used to produce a world-class finish. The challenge is to build the car to the tight specifications required by the engineers. They're confident, even excited, that with advanced technology and highly trained people, they can do the job.
Then we got a mission and we can accomplish it. You bet.
Accidents happen, so GM engineers study the car's interior, looking for ways to make it friendlier. Friendliness, safety is in the details.
That's better. This new interior and the seatbelt, there's not a mark on it.
Engine control computer from Delco Electronics. Steering units from Saginaw Steering Gear. 11,000 parts, designed and manufactured within stringent specifications, whether made by GM or an outside supplier. The quality of the car depends on it. After nearly 2 years of planning, engineering, and testing, the first hand-built prototype is ready to roll.
If you're satisfied with that mounting, Dave, let's get the testing started.
Okay, Vince.
The V8 gasoline engine accelerates in the prototype for the first time, and the diesel, and then the long tests begin. Mile after mile, day and night, stopping, starting, accelerating. City schedule, highway schedule. Through heat, mud, water, cold, testing for durability, emissions, making changes, improvements, simulating a lifetime of use in accelerated tests, running prototype cars up to 50,000 miles and more on schedules that stress metal and machines. In this, GM's most extensive test program, these cars will run over 4 million test miles, and they will be built in volume to stringent specifications. For example, tolerances of plus or minus 3 millimeters used to be considered good on these body parts. On the new car, engineers are working toward tolerances of plus or minus 1 millimeter or less. Parts that don't meet specifications are rejected. Now the engineers go for a drive in the prototype to California and back.
Back the last couple of days.
Good. It looks like the changes you made.
It's called soak time, living with the car, because that's what the customer does. At GM, no car is completed until the car is passed by the customers one last time. Every GM car and truck is previewed in customer clinics. Customers give written comments on design, comfort, roominess, serviceability, even colors. It's a hit.
I hate red cars.
With almost everyone. Some people think these are just details. GM puts them to the test. All of them. Nobody sweats the details like GM. And now GM's experts evaluate the cars in ride and drive tests near the desert proving ground. They examine the cars in detail. They compare the car lines to each other, to past models, to the competition. Drive one car, switch. Drive another. They conclude that the comfort, serviceability, performance, and efficiency of design are astonishing. The decision is go. This is one of 33 hand-built prototypes costing $650,000 each. Now, before the design is locked down, it's time to verify the countless hours of laboratory computer simulations. This is it. Carrying advanced anthropomorphic dummies developed by GM, the car heads toward the barrier. The test is studied from various angles. The car meets the 30-mile-per-hour federal frontal barrier standard. Then, and then, it's hit again, and again, and again, and again. Before the first customer drives this new 1985 luxury car from GM, 72 of them will have had their moment of truth, confirming their crashworthiness. Before the car is built, the builders go to school.
Statistical process control is a method
because it takes training to compete with the world's best.
Controlling the process.
And they're getting it. More than 1 million hours of training at each plant for the people who will build the new GM car. They're younger, better educated. And here they'll be using their heads more than their backs. So they're learning to use statistics to control the production process and how to utilize some of the most advanced technology in the industry. Because that's how you do it. By giving good people, smart people, the knowledge, responsibility, and authority to do the job. And by getting rid of a big inventory where unacceptable parts can stack up only to be rejected later. Instead, there's a just-in-time material system and automated vehicles to distribute parts.
When this car gets in here, we make all
Finally, the plant is ready for a tryout, building the first pilot cars.
That's great, Gene. The changes are made back in
Slowly, stopping over and over.
Sure would, Vince, because it sure looked good.
I'm glad you suggested that, Bob. Let's
Check it, analyzing, correcting the fine
let's
details,
get those changes made.
and do it again and again. After 4 years, $3 billion, and almost as many details, a car is born. It is individually engineered with technology applied to meet customer needs. The body starts to take shape. 157 robots operate in the assembly process. Bodies are electrostatically primed, rust-proofed, smoothed, and painted. And painted. And painted. And painted. The electrical system receives over 1,000 circuit tests. The interior components are installed. Door seals and windows are fitted and face a trial by water. The details of the job are checked. The fuel-injected V8 and drivetrain are installed in one operation. The car faces a computer-controlled test at the end of the line, testing engine, brakes and details, dozens of details, checking, a machine that sweats the details. In 210 weeks, a car is born. The new 1985 front-wheel drive Cadillac is on its way to the showroom. Then to the ultimate test, the judgment of the customer. Nobody sweats the details like GM.